How do y-intercepts determine if lines are truly parallel in algebra? Have you ever wondered how to tell if two lines are truly parallel in algebra? It's a common question, and today we are going to break it down in a simple way. The key to understanding parallel lines lies in their slopes and y-intercepts. First, let's talk about slopes. The slope of a line tells us how steep it is. For two lines to be parallel, they must have the same slope. This means they rise and run at the same rate. If you think of a hill, if both lines climb at the same angle, they will never meet, which is what makes them parallel. Now, what about the y-intercept? The y-intercept is the point where a line crosses the y-axis. It helps us see where each line starts. While the y-intercept does not determine if lines are parallel, it plays a role in distinguishing one parallel line from another. For example, consider the lines represented by the equations y equals to x plus 3 and y equals to x minus 1. Both of these lines have a slope of 2, so they are parallel. However, their y-intercepts are different. The first line crosses the y-axis at 3, while the second crosses at -1. This difference confirms they are distinct parallel lines. But what happens if two lines have the same slope and the same y-intercept? In that case, they are not two separate lines at all. They are actually the same line, overlapping perfectly. This is why it is important for parallel lines to have different y-intercepts. To sum it up, the y-intercept helps us identify where each line crosses the y-axis, but it is the slope that truly determines if lines are parallel. Without different y-intercepts, lines with the same slope would overlap instead of being parallel. This understanding is essential when graphing linear functions and analyzing their relationships in algebra. So next time you graph lines, remember to check both the slope and the y-intercept to see if they are truly parallel.